OpenRail is kind of my small fun project. It's open source implementation of Rail language. Probably, if you worked with Dynamics products, you heard about Rail. Rail, it's intermediate representation language for machine code. Why do we need intermediate representation languages for machine code? Well, first of all, machine code is very complex. It has side effects. Modern architecture has a lot of instructions. And when you're writing some code analysis software, it will be really complicated to deal with it. OpenRail has only 23 instructions. It has no side effects. And it's super awesome if you're writing some things like deobfuscators, decompilers, some stuff for automated vulnerability detection, and so on and so on. OpenRail is based on BAP, which is based on VEX. So you can use it from native application as well. Also, it has Python bindings and low-level and high-level Python API, which has a lot of cool things like binary parsing, like code optimization, like building of that data flow and control flow graphs, and other stuff.
Okay, but we can't go on forever, right? So here you go.
Oh, thank you.
Yep.
Cheers.
Okay, now they are working.
Do you see it? Or I should make the font larger. Wait a minute. Okay, as I told, it uses Python. So OpenRail has interfaces to IDA, GDB, WinDebug, and other debuggers. But today we're going to use it as standalone application. So first of all, we need to import all the things. Now we will try to load some simple binary and transform it to Rail. No, okay, now we need to create translator instance. Oh. Okay, you should. Ah, fuck. Okay, the problem was I tried to start it from OS X while it was built from Linux, so now I'm SSHing to my Linux box. Software sucks, actually. Stupid background. Oh, finally. Well, I just want to be sure that it compiled properly, so I just build it and running some unit tests. Now we starting to work.
If you're feeling stuffy,
Okay, I loaded PI binary to Rail. Now we will try to translate some simple function to intermediate representation. Here is hard-coded address of the function. And finally, it works.
well done.
As you can see here, we have machine instructions and intermediate language instructions for this assembly code. It uses 3-address form.
I'll be nice to you. I'll be nice to you. I'll let you finish it off. 1 minute. I'll let you finish it off. Because I can't let you go on and on and on.
As I said, Rail can do a lot of other things. Now we will try to build a data flow graph and run some basic data flow optimizations like constant folding, dead code elimination, and common sub-expression elimination on this translated code. So now we will print the IR code of optimized function. Well, as you can see now, it looks much more simple because during dead code elimination was removed a lot of junk code like unused flux computation and other. And well, currently it looks pretty close to the original machine code. So as you can see, there is not so much of overhead. Also, you can save data flow graph to dot file and render it to picture.
Okay.
However, Rail is open source. You can download it at GitHub. It has well, pretty good documentation with a lot of examples. So if you have some questions, you can ask them to me after the conference. Thank you.
Yeah, okay, thanks.